So I just kind of want to review what a vertical asymptote is and what a horizontal asymptote is. So this is some review. Okay, so a vertical asymptote. Okay, so let me just kind of give you a picture of what a vertical asymptote could do. So let's say we have a vertical asymptote maybe at x equals a. So let's say this is where a is. And usually we denote a vertical asymptote or asymptotes with a dotted line. They're not on the graph, but it's there kind of showing us that there's an asymptote there. So what's going to happen is as your value of x gets closer and closer on the left, this graph is going to either shoot upwards and go to infinity. So it can come up like this. Could have come down and went down to negative infinity. And as we come in on the right, you might be going in a different direction. Or you could be going into the same direction. But here's an example of what a vertical asymptote could look like at x equals a. Okay, so that's a vertical asymptote. I'm just going to call it VA. And so in words, as x gets closer, as you get closer and closer, to x equals a, the function goes to positive or negative infinity. So technically, looking at this picture, if I looked at the limit as x is approaching a on the left-hand side of our graph, maybe call this f of x. This is not going to any one y value. Notice that this is getting steeper and steeper. It's going off to positive infinity. So this is equal to infinity. The limit does not exist here. But a lot of times we want to know what's happening to our graph, and so we will state that it's going to positive or negative infinity. So if we looked at the limit as x is going to a on the right, of this f of x. So as we're getting closer and closer to x equals a on the right, notice that this graph shoots downwards. And so this would equal negative infinity. But again, that limit does not exist. But with a graph, we can tell what's going on, though, at that vertical asymptotes, knowing that. So if we had the function and we plugged in numbers close on the left, you'll notice that it's not going to one y value. That number, when you're plugging into the function, would getting larger and larger and larger. Same idea, though, when you're plugging in numbers to the right of a, if you had the function, you notice that as you got closer and closer to a on the right, that number would be going to negative infinity. The absolute value of that number would be growing. Okay, so that's what a vertical asymptote is. A couple things about vertical asymptotes that you should know. A graph never crosses a vertical asymptote. Okay, so that's a value where x actually, if we have a rational function, and that's a value which sets our denominator equals 0 and not our numerator. It can cross a horizontal asymptote though. So let me show you what a horizontal asymptote is really quickly. So a horizontal asymptote So maybe we have some horizontal asymptote at x equals or y equals b. So I'm going to denote that by a dotted line again, horizontal dotted line that goes through b. And so what's happening here is as your function is going to infinity, as x goes to infinity, your graph is going to start hugging this horizontal line. I might have something like this. So we have a horizontal asymptote at y equals b in this case. And then how we can write this using limits, if I look at the limit as x is approaching, let's look at negative infinity first, of, let's call this g of x, of g of x. So again, with limits, this is actually not going to one x value. It's going to, x values are getting smaller and smaller and smaller, going to negative infinity. We want to see what's going on with our y value. Well, as this is going off to negative infinity, our y value is getting closer and closer to hugging this line y equals b. And so the limit as x goes to negative infinity of g of x, this is going to equal the y value of b. And if we look at the limit as x goes to positive infinity of g of x, notice it's still going to one y value. It's getting closer and closer. So as x is going to positive infinity, looking at what's happening to y, that y value is getting closer and closer to b. Okay, so those limits actually exist at horizontal asymptotes, and they're the end behaviors of our graph. A graph can cross a horizontal asymptote. So it can't cross a vertical, but it can cross a horizontal. If it crosses that horizontal asymptote, it's still going to hug it. So for instance, if this was coming down and it crossed this asymptote here, it's still going to hug it on the other side. It's still going to get closer and closer to that as it goes to infinity. Okay, so that's kind of a quick review of vertical asymptotes. Maybe let's take a break and I'll come back, and if you want, we can go over a couple of examples. And then we'll look at limits as x is going to positive and negative infinity of functions and seeing if the limit exists. And if it does, that means there's a horizontal asymptote. And what is it? What is that y value it's going towards?